believe we did this one. Did everybody find this one in their packet? The one that says definitely not it. Say solving quadratic equations by factor. They when you did the rest on your own? Do you have that one done on the paper? I don't think we did that one. You might have done it on your own, but I don't think we did it. Oh, did you guys do that? All right, so what was the first step for any quadratic equation? First step. First step for any quadratic equation. No. No, if you saw the notes in front of you, there's literally a 1 right next to it. It's the first step. Yeah. Yeah, set the equation equal to 0. How many terms do I have in the entire equation? 3. All 3 have to be on the same side. And I need them to be on the side where the number that's in front should be positive, because if not, factoring is going to be difficult. So right now, the lead term, the one that has the biggest exponent, is that p squared is the biggest exponent. What does it have in front right now? It has a 1, and so I want it to stay positive. If I were to move that over to the right, it would become negative, and that's going to give me a headache for factoring. So I'm going to do minus 40 and plus 3p. But I also want to be aware of what standard form is. Putting them in order from biggest exponent to least. So I want to make sure the p squared goes first, but the plus 3p should come second, and then the minus 40. Enjoy this one while you can, because the majority of the ones I'm going to focus on today don't have a 1 in front. It's going to be a different number. Makes things a little more challenging. All right, so now that I have all the terms on one side, I'm ready to factor. What's the first thing we look for when we factor? I think somebody already said it. Yeah, is there a greatest common factor? Do all three of these terms have one common term that they can all be divided by? No. What's the next thing we look for? No. With 3 terms, what do we look for next? Seems like forever ago, huh? Seems like it was last month. Oh, that's true. It was last month. Fried chicken? Huh? Well, there's something we can try really quickly before a factor chart. It would be I guess you'd have to go to the notes before and look under 3. Yeah, can this be a perfect square trinomial? And I don't have to waste a lot of time on it because I can tell by looking at it. The first and last have to be positive. 40 is not positive. They also have to be perfect squares, and 40 is not a perfect square. Yes, in this particular case, the only thing I can try is a factor chart. A is 1 for the last time today. B is 3, and C is negative 40. So we do a 2-column table where we multiply A times C, that gives me negative 40, and then I put B on the top of the second column. Yes, you got the worst part of the deal because you have the more mathy part, but I did help you in this by giving you like a little cheat sheet where if you take care of the multiplication, I take care of the signs, and you just have to remember to study. So you have to come up with all the combinations of numbers, and really you don't have to do all of them, but if you're having trouble finding the correct combination, it would behoove you to come up with every combination of numbers that multiplies to give you 40, which I have now done for you. All those numbers, when you multiply them, give you 40, but then I gave you the adjustment for the signs in order to potentially make them add up to 3. What did I tell you to do with the signs in this case when you have a negative on the first column and then a positive? Say it again. Very good. Make all the smaller numbers negative and the bigger numbers positive. So then the last question is, do any of these add up to 3? Yeah, negative 5 and 8. Because A is 1, so this will be the last time that A is 1 today, I can go straight to factored form. So let's just get these two numbers and get the variable. So say P minus 5 and P plus 8, but don't forget this was an equation. So I am now done factoring. On the test this Thursday, they won't all be equations. Some will be just expressions, but there's not a big deal. Like, I'm able to review for that even now because that just means the problem would look like this. There wouldn't be an equal sign. It would just be that. So I get to kill 2 birds with 1 stone. What does the next step say to do after we factor? Yeah, now that we know what our factors are, make each factor equal to 0. P minus 5 is equal to 0. P plus 8 is equal to 0. And then solve each one. Josh is an excellent solver. Need some help, let him know. So this equation has 2 solutions. When an equation has more than one solution, you may see it written as a solution set. You would write the variable, colon, and then number. Do not confuse this with ordered pair. That is not the same thing as saying x comma y. It's just saying that there's more than one number that P could be. Any other questions here? All right. Jose, did we do this one? I feel like we did the next one or 2 after that. Yeah. That one we did. We did the one after that. That one we did too. Jasmine, you agree? Okay. How about this one? This one we did too. The one with the V's on it. Andrew, you got that one too. Okay. How about that one? No. So let's do this one. What's the good thing about this one? Okay, it's already equal to 0. Good. So now we can just start in with the factoring. Okay. With 3 terms, what do we look for first? Do we have a greatest common factor here? No, we do not. What do we look for next? Perfect square trinomial. Could this be a perfect square trinomial? Well, even though the first and last term are positive, they are not perfect because 2 is not a perfect square. If you take the square root of 2, you get a decimal. So throw it away. The only thing that might work here is a chart. But look, this is already getting my attention. When it comes to doing a chart, when the number in front is not 1, there's going to be a couple extra steps we have to do. I tried to give you a watered down version of how to do it, but even then, A is 2, B is negative 5, C is 2, 2 times 2 is 4. Luckily, this chart won't be very big because there's not many numbers that multiply to give you 4. 1 and 4, 2 and 2. I took care of the signs for you. All you have to do is memorize them. This would be negative, negative, yeah. Because negative 1 times negative 4 is positive 4, and then when you add them, that does give you negative 5, so that's what I wanted. Now here comes the extra part, right? So by habit, and I think it's just more out of laziness, I get too many kids because there's a limit to what they want to learn. They'll only learn so much, and then that's it. No more, no más, no más, no más. And they're going to want to get here and just write m minus 1 and m minus 4. But you can't do that because if you multiply that, you're not going to get what you started with. So what I taught you is kind of a shortcut that says, all right, put a 2 in front of each one, but you can't leave it like that either. You have to check and see if any of those factors have a common factor that they can be like reduced by. and then go ahead and reduce them. You're not going to do anything with the number, but you just have to divide it out. Does the 2m minus 1, can that be factored any further? Can that be reduced? No. How about the second one? Yeah, by 2. Both even. So I get 2m minus 1 and then m minus 2. By this point, I have factored. If I were to multiply this, I would get what I started with, but I don't want to multiply it. Neither does Jonathan. So now let's just make each factor equal to 0. 2m minus 1 is equal to 0. M minus 2 is equal to 0. As I learned from some other classes today and stuff, the attention span is even less than normal. So I'm going to try to limit the amount of time I just spend just writing. Like basically here, long story short, at this point I'm going to write the solutions. Like if anybody's going to make a mistake, I think it's going to happen once you get here. I doubt if you're able to get this far, I don't think you're going to make a mistake there. If anybody wants me to explain how I got either of these two, you let me know. I would hope that you guys would write the work in, but if you know how I got them, then I'm ready to move on. As a solution set, this would look like this. I just want to keep things moving. So, does anybody not know how I got any of those numbers? Okay. Did we do this one? No. Okay. First step. Make it equal to 0. It's not done for you here, so we have to do it. Minus 18, minus 18. So if I write this in standard form, 6n squared minus 3n minus 18 is equal to 0. What do we look for next? Is there a greatest common factor, Jasmine? Yeah, all of them can be divided by 3. So remember, greatest common factor is the opposite of distributive property. I'm going to bring the 3 out. That leaves me with 2n squared minus n minus 6. I don't want to distribute. Jair wants to distribute, but I don't want to distribute because I don't want to go backwards. But if I were to, I would end up with what I had before. A new Kit Kat?
Looks packy.
No, I don't have any more. Well, there is a way on the e-class page. You can go on there, print it out on your own. Yes, it's available. Last Wednesday.
How are we going to be?
Think about it. Get back to me. All right. But then we got to look on the inside and see if that can be factored any further. Well, it's not a perfect square trinomial because the 6 and the 2 aren't perfect. And but I might be able to do a chart. 2 times negative 6, Jair is negative 12. This is a perfect example. Like, I don't expect every single person to have to do an entire chart. Like, I think a lot of you should be able to know in your head, hey, that's easy. That's going to be a positive 3 and a negative 4. But if for some reason, if you don't, then this at least gives you like a set of steps to follow each time. 1, 12, 2, 6, 3, 4. When both columns are negative, what do you do with your signs? Small positive, big negative, and then like I said, the one you end up getting is positive 3 and negative 4. But wait, there's more. Are his shoes fly also?
Yeah.
So keep that in mind when you go to factor. These are n's. So you're going to put that 2 in front. Now also don't forget we had a GCF here. The GCF was 3. It's not going to affect my solution. What do I solve equations for? When I solve, what am I solving for? For a variable. In this case it's an n, but it's for a variable. Since that 3 doesn't have an n attached to it, it's not going to affect my solution. But I will write 2n plus 3 came from here, and then 2n minus 4, the minus 4 came from there, and then we're still equal to 0. But this is just temporary. You got to go check in the parentheses and see if I can reduce them. Can I reduce 2n plus 3? No. Can I reduce 2n minus 4? Yeah, by 2. So I have 3, 2n plus 3, and minus 2. How many factors do I have? I have 3 factors. A factor is a number that you're multiplying. I have 3 factors, and I'm supposed to make each factor equal to 0, but the purpose of that is to solve. And we solve for a variable. That 3 in front does not have a variable, so I can ignore it. When I make each factor equal to 0, I'll just say 2n plus 3 equals 0. I'll just say n minus 2 equals 0. And instead of spending more time solving this, I'm just going to assume that if you know how to get this far, the last couple steps are not going to trip you up. But if you can I just tell you that this is negative 3 over 2 and that this is 2? Does anybody not know how I got those? I'd be happy to explain. If that's not to say that you can't put it on your paper, like how to solve. I just know that's what you're going to end up with. And then you would write a solution set. Seabass, any questions? This next one, did we do this one? Okay. I'm gonna do this one, and then after this one, we're gonna skip to the end and work our way backwards because there's some interesting ones towards the end, just to make sure we get to as much as possible. First step, make it equal to 0. I also want to make sure I end up with a positive in front, so I can do it by doing minus 5p. If I put everything in order, I get that. Do I have a greatest common factor? No, because it's possibly be a perfect square trinomial. No, because the 3 is negative, 2 and 3 are not perfect. So that leaves me with a chart, but luckily it's not going to be a very big one. Because 2 times 3 is 6, and there aren't too many numbers that multiply to give me 6. So 1 and 6, 2 and 3. When the first column is negative and the second column is positive.
Small positive.
Very good, small positive. Big negative. But Jair is very concerned. Very concerned. He sees again that A is not 1. So he can't just write P plus 1 and P minus 6. He's got to write the 2 in front. 2P plus 1. 2P minus 6. Can any of those factors be reduced? Which? The second one can by 2. So we get 2P plus 1 minus 3. 6 divided by 2 is 3. Oh, yeah. Make each factor equal to 0. Solve. If you want me to show these last couple steps, Jonathan, is that what you want? You're telling Sebastian? Not just take my word for it, since it's giving you negative 1/2. This gives you 3. All right, so let's do this now. Let's skip to the end. And I know I did a few of these also for you, so you're going to have to let me know. Did I do this last one here for you before we left? You did? Jasmine, you have it as well? This might have been towards the end. Some of you like to pack up early. Okay, this one I do have. How about this one here? Okay, so let's do this one. What's the good thing about this one?
30.
Josh, the earbud made it back in your ear. It should not be there. Thanks, Josh. It's already equal to 0, good. But now when it comes to factoring, now we have two terms. So the methods for factoring are a little bit different. We can still look for a greatest common factor first. Do we have one? Do we have a greatest common factor? No. So there's going to be only one other way. And if it can't, then it can't be factored. And if it can't be factored, at least now we're not going to know how to solve until next week. Next week we'll learn some other ways for solving. Luckily, this can be factored. What's the only other way that we know how to factor two terms? What did we call it? Thankfully, we have it already printed on a sheet of paper. Huh? Thank you. Difference of squares. Where the difference means the minus. You don't have to show this step, but this is more just to show you so you see it. If these are perfect squares, or I can multiply one term to get them, then I have a difference of squares. What times itself gives you 16x squared? Not just 4. 4x. What times itself gives you 1? 1 times 1 is 1. And then the $1 million question, where I did not print it for you, but I wrote it for you, told you to write it, told you I was going to keep on asking you over and over again. What does a difference of squares look like in factored form? Conjugates, thank you. Conjugates. 4x plus 1, 4x minus 1 plus 0. That takes care of the factoring for us. Come on, hang in there, Jasmine. 4x plus 1 can be 0. 4x minus 1 can be 0. Solve each one and then celebrate. This x ends up giving me negative 1 over 4. This one gives me positive 1 over 4. You want to go sit next to him again? You miss him? Hair song. Are his shoes fly? They're pretty cool too. For this one, I'll go ahead and just to show you the solution set, because are those two solutions the same? No, they're not. They're different, but they look very similar. The only difference is the sign. So you might see this written this way. And if you do, that still means that there's two solutions. It's just one is positive and one is negative. Checking out all the guys' shoes. See which are the flyest. Did we do this one? You sure we didn't do this one? No. First step. Make it equal to 0. But how many terms do we have here? 4. So there's 4 terms we're gonna have to put on the same side. In order to keep the lead one positive, I'm gonna have to move these to the left. But something else happened here, and I was happy my third period noticed this before I even said anything. When I put all those terms on the same side, what do you notice is happening? What do you notice is happening? What about those two terms? Well, there's a word for that. The two terms are like. Those are like terms. Not because they like each other and they want to be married one day. It's because they're going to be combined. 21 minus 10 is 11D minus 35. Oh no, rattlesnakes. When it comes time to factor, do these three terms have a common factor?
No.
They do not. Could this possibly be a perfect square trinomial? No, so we end up in Chart Town, and this is going to be the biggest chart we've done so far. I don't remember how we've done one bigger than this. We get to use those multiplying muscles. Because 8 times C, 6 times negative 35 is negative 210. See, this is one of the things that I don't like about the X method, and I can't, I'm not for it, I'm not against it, but like next period, I have a couple kids who are in love with the X method, and I would love to see them come up with this. They might be able to. This was not that hard. Since the 21 ends in the, since the 210 ends in a 0, it's not too hard to do, but this is not something where I think a lot of you guys can do mentally. So at least by doing the chart, you can just use the calculator and do, 210 divided by 1, 210 divided by 2, 210 divided by 3, 210 divided by 4, coming up with your combos. I can do them in my head because I'm awesome. Because Jair allows me to. 5, 42, 6, 30, 8, no, 9, no, 10, 20, yes, 14, 15. Under this sign scenario, how do we adjust our signs when the left column has a negative and the right column has a positive? Small negative. Big. Another way you can maybe even think about this. Yeah, I'm trying to think this way. I've never really showed it this way, but I'm just trying to see if I can maybe disprove it. But yeah, I believe the logic here applies. When you see a positive there, the big one has to be positive. So your only question remains, well, do they both have to be positive, or is it only the big one? If you have a negative here, then it's only the big one. If you would have had a positive there, it would have been both of them positive. Maybe that helps. If you have a negative over here on this side, the big one has to be negative. Has to be. Then the question is, are they both negative, or is it only the big one? The big one's always going to have the same sign as what's there. You just got to figure out if they both have to have the same sign or not. Maybe that's another way to remember it. On the test, you're not going to have your notes. Do any of these add up to 11? Negative 10 and 21. Because A was not 1, though, we have to put that in front. These were D's. So 6D minus 10, 6D plus 21. Can the first parentheses be reduced? Yes, it can by 2. They're both even. Can the second one be reduced? Diane, it's harder to see what you're doing. You have to put that on the desk. Huh? Yeah, you can divide by 3 there. So 3D minus 5, 2D plus 7. Even if you don't have the packet, you can still, like the cavemen used to just write on blank sheets of paper. No, they had paper and pencil, but it was just there was no printers back then, so they just wrote on blank sheets of paper. I had from the Geico cavemen. Now that I finished factoring, make each factor equal to 0. I can tell you this is going to give me 5 over 3. This one's going to give me negative 7 over 2. I did it in my head. If you want me to show you, I can. I'm just gambling that due to our limited attention span, I would think if you made it this far, I doubt you'll make a mistake down here. So we can just keep things moving. Did we do this one together? That one you have already? Jasmine, you agree? Okay. Let's keep on working our way. Oh, this one's too easy. Let's go to this one. Let's go to the. What's good about this one? It's already equal to 0. But now we have 3 terms on the left side. What do we look for first when we try to factor them? Okay, do those 3 terms have a greatest common factor? They do not. Could this possibly be a perfect square trinomial? Yes, it could. Now the good news is that if you forget to look for it and you move on to a chart, you'll still get the same answer. And that's at least a good thing. But watch. Are the first and last term positive? Yes. Are the first and last term perfect? They have to be perfect squares. Yes. If you take this, what times itself gives you x squared? You don't have to go back. I can see it. X. X. Thank you. X times x is x squared. And that's so. This is the last time I've written this maybe 3 times on the board. I'll write it for you one more time.
Don't you wait.
I really want to talk to Jonathan. Turn around again so I can tell him something. Please. A is 1, B is -8, C is 16. Is that what? Yeah, Diana, 16 is a perfect square. That's what people ask me. So we're checking to see if -8 squared is equal to 4 times 1 times 16. And it is. Okay? Get that out a little wind. Hey, Orly, you're awake today, man.
I never knew where we're spring break. Went to Orlando.
You got to meet Mickey Mouse. So we just verified that look, you get the little zip check. It's verified that we have a perfect square trinomial. So now you just gotta remember how to factor it. A perfect square trinomial is gonna be just one parenthesis. Instead of the second parentheses, we put a square on the outside. You remember from before, we're going to borrow the sign in the middle. And then those perfect squares that we just asked, so hey, you did such a good job. What times itself gives you x squared? What times itself gives you 16? And now this is factored. There are 2 factors, that's why the square is here. But when it comes to solving, you only got to put the parentheses. So just say x minus 4 is equal to 0. So x is 4. Fax machine. Alright, let's keep on working our way up, see how far we can get. Skip the word problem. There will not be word problems on the test this week. Let's go to this one here. First step. No, first step is make it equal to 0. Put all the terms on one side. So I'll do minus 15 and I'll combine the like terms. 4a squared minus 18a minus 10 is equal to 0. Okay, next step. Do we have a greatest common factor? Yes, we do. How do you know that we have a greatest common factor for shizzle? Because all the numbers are even. So I can bring out a 2. That leaves me 2a squared minus 9a minus 5. Look at the leftovers. Can the leftovers be a perfect square trinomial? No. So let's try a factor chart. 2 times -5 is -10. This could very well be one that I would think you could do in your head. But to multiply to get 10 is 1 and 10 and 2 and 5. When the second column is negative, you know the bigger one is going to be negative. But now I got to figure out, are both of them going to be negative? And the thing is, since the other one is negative, no, they can't both be negative. This has to be positive. Negative times positive gives you negative. How many of these add up to -9? Yes, they do. 1 minus 10 is negative. We still have the first 2 on the outside. Then this 2 comes and jumps in front, and we have 2a plus 1 and 2a minus 10. Can any of those factors be reduced? JJ? Yeah, these can be reduced by this addition. So we get 2a plus 1, and then a minus 5. When it comes time to set each factor equal to 0, even though this 2 in front is a factor, I can ignore it. It's not going to affect my solution because it doesn't have a variable. So 2a plus 1 can be 0, and a minus 5 can be 0. I'll use my fancy math skills to save us some time. A can be -1/2, and A can be 5. Don't know how I got those, holla. I think you have the voice of an angel.
Appreciate it.
His name is Angel, but you have the voice of an angel. This might be the last one. We'll see how much time we have after this one. First step, Jasmine. So on this one, should I put all the terms on the left side or the right side? Well, see, the thing is, because if I put them on the right, I would do this, but then I'm gonna end up with a negative in front of the square, and we don't like that. You don't like it? No. So we're gonna go plus 65, a plus 18. Think Jonathan found any fly guys in the hallway? Fly shoes. (7a squared plus 65a plus 18). Do these 3 terms have a greatest common factor? Could that possibly be a perfect square trinomial? No, even though the first and last are positive, they're not perfect. What scares you more, that or Jesus Christ. It's more fun when somebody's sleeping. Oh, God. So here's going to be another big chart. 7 times 18 is 126. Now, at least, even though we have big numbers here, at least we know everything's going to be positive. Johnny Bravo, put it away. Johnny Bravo. 63. 3 will not, well, actually 3 will work. 3 is going to work. 4. 42 times. Somebody check my math there, but I think it's right. 42. 4 won't work.
That's right.
5 won't work. 6 will work. 7 will work. It will. I think it's 18. Doesn't matter, because I mean, can you already tell which was the one that we're gonna end up using?
No.
You can't, but other people can. 9 will work. 14 times 10, no. 11, nah. 12, oh, alright, whatever. There might be another one, but I don't think so. I think this is it. And this is all positive, like we said before, which is the winning combination. Yeah. But sadly, since A is not 1, see, if A was 1, I can just do A plus 2 and A plus 6. Put it away, put it away, put it away, put it away. 7A plus 2 and 7A plus 63 still equal to 0. Can either of these be reduced? Yeah, the last one by 7. So we get 7A plus 2, A plus 9, make each one equal to 0. So 7A plus 2 is 0, A plus 9 is 0. I know that my A's look like 9s and vice versa. A is negative 2 over 7 and A is negative 9. You throwing up gang signs? Oh, you're rapping? Spitting on fire? Any other questions? All right, we'll stop it there.
I don't know.